Example 6, find all zeros of this function given that 2 plus I is a 0. So a couple of things. I see x to the 4th. I'm expecting there to be 4 zeros. And they give me one of those zeros, so it's kind of nice when they do that. 2 plus I is a 0. I know from the conjugate zeros theorem that 2 minus I would also be a 0. So here's what I would do. If I know a 0, I'm going to use that and synthetic division to break it down. So let's use 2 plus I and see what happens. We've got 1x to the 4th minus 1x to the 3rd minus 17x squared plus 55x minus 50. Add straight down. And multiply, we get 2 plus I. Add straight down, I've got 1 plus I. Okay. So I'm going to have to FOIL or something. So let's do that over to the side. I'm going to have to multiply 2 plus I times 1 plus I. This will be 2 plus 2I plus I plus I squared. That's negative 1. So 2 minus 1, that's 1 plus 3I. 1 plus 3I. Add straight down. Negative 17 plus 1 is negative 16. So negative 16 plus 3I right there. I'm going to have to FOIL again. So I go 2 plus I times negative 16 plus 3I. Distributive property, that's negative 32 plus 6I minus I plus 3I squared. 3I squared, that's minus 3. So we're looking at negative 35 plus 5I. Did I make a mistake there? It's negative 32, 6I. Oh, yeah, I did make a mistake there. Because nobody caught me on this. That's negative 16. So when I distribute it right there, that's negative 16I. Negative 16I. Okay. So everything else is right. Everything else is good. We've got negative 32 minus 3 is negative 35. 6I minus 16I is negative 10I. Okay, be very careful. You don't want to make a little arithmetic mistake because it's going to blow everything up. So negative 35 minus 10I right there. Okay, add straight down and you get 55 minus 35 is 20 minus 10I. Okay, so I've got to do it again. I've got to FOIL again. Hopefully I won't mess it up this time. 2 plus I times 20 minus 10I. Okay, distribute. 2 times 20 is 40. 2 times negative 10I, negative 20I. I times 20 is plus 20I. There's a good sign. I times negative 10I is minus 10I squared. Those two cancel out. Negative 10I squared is plus 10. So 40 and 10 make 50. That's 50. Add down, and that's 0. Okay. I knew it was going to be 0, though, because they told me 2 plus I is a 0. But, okay, that's great. Fine. Whatever. I also know, because of that conjugate zeros theorem, I knew that 2 minus I was going to work, too. So what I'm going to do is I'm going to take these numbers right here. Forget about the 0. Don't need it. And I'm going to work on 2 minus I. Okay? So do the same process. Add straight down is 1. Multiply, we get 2 minus I. Add straight down and the i's cancel, which is kind of nice. We get 3. And multiply 2 minus I times 3. That's going to be distribute. That's 6 minus 3i. 6 minus 3i. Okay, cool, because when I add down, the three i's are going to cancel. I get negative 16 plus 6 is negative 10. And multiply, distribute, that's negative 20 plus 10i. And notice both of those cancel out. You get 0. So I didn't even have to FOIL that second time through. Okay? But also, girls, you have a question? You good? Also, what I've done is I've broken down. The first time I divided, I got down to x to the third. And the second time I divided, I got down to x squared. And so what I'm looking at right now is 1x squared plus 3x minus 10, which you should probably know how to factor from Algebra 1 class. Two numbers that multiply to negative 10 and add up to 3. What are they, 5 and negative 2? Okay. So I've got my zeros. We need to find the zeros. Those are the factors, but you're going to have zeros of negative 5 and positive 2 there. So make sure you answer the question. Find all the zeros. All the zeros are negative 5 and 2 plus I and 2 minus I. 4 solutions, 2 of them real. All right, last thing, Descartes' rule of signs. It talks about the number of positives and the number of negatives. So you can read through this, but it's really hard to read, okay? Let f of x define a polynomial function with real coefficients of non-zero constant term with terms in descending powers of x, so it's just in standard form. A, the number of positive real zeros of f either equals the number of variations in sign occurring in the coefficients of f of x or is less than the number of variations by a positive even integer. Okay, so that seems kind of tough, but first of all, we're talking about positive real zeros. Okay, and it's talking about f of x. So for number 7, let's do that one first. 7a says determine the possible number of positive real zeros. Okay, so this isn't that hard. You look at f of x and see how the first term is negative, and then the second term is positive, and then negative, and then positive, and then negative. Okay. They're talking about the variations in sign. When they're talking about the variations in sign, they're talking about when does it change, okay? The number of variations in sign. So see how it changes from negative to positive? Change, change, change. It's changing from negative to positive and then changing from positive to negative. I see 1, 2, 3, 4 variations in sign. 4 sign changes, okay? So this answer is either 4 or, and then it says less than the number of variations by a positive even integer. Basically what you're going to do is subtract 2 until you get to 0. Okay? It's either 4 or 2 or 0. So think about the question that was asked. You might see 4 solutions to that thing, but how many of them are positive real zeros? Either 4 or 2 or 0 are positive real zeros. Now, part B is a little bit harder because you have to look at f of negative x. So pay very close attention to this. Negative real zeros, you have to look at f of negative x. And it's basically the same question, but you're looking at f of negative x or f of opposite x. So think about what happens if you change x to negative x. Okay, I change x to negative x, and I'm looking at it, okay? And if you look at this first term, I see 5 negatives. Do you see 5 negatives? There's a negative 2, and then there's a negative x to the 4th power. I see 5 negatives, so that result, whatever it is going to be negative. And then I look at the next term, and I see how many negatives there. I see 3 negatives, so that's going to be a negative result as well. The next term, I see negative 5 times negative x squared. There are 3 negatives there as well. That's going to be negative. And the next term has 4 times negative x. Well, that's definitely negative, and this one is definitely negative. So remember what we're talking about. We're talking about the number of variations in sign. How many times does the sign change from negative to positive or positive to negative? How many? None. So 0. There would be 0 possible negative real zeros. Okay?